Hello out there, welcome to this tutorial on trigonometry. In this video, we'll be looking at trigonometric ratios. So we start with definition. For any acute angle of a right angle triangle, the ratios of the sides with respect to the acute angle are known as the trigonometric ratios of the angle. So we consider the diagram below. This is right angle at this point. The given angle theta is here. We then identify and name the three sides of the triangle. So the longest side, which is always opposite the right angle, is called the hypotenuse. And the side opposite the given angle, this side opposite this given angle, is called opposite, and the third side is adjacent. You just need, out of the three sides, to be able to identify two sides. Then you know the third side will give you the third name. So we now state the trigonometric ratio. The three basic trigonometric ratios are, we start with sine theta. Sine theta is opposite over hypotenuse. Sine theta is opposite over hypotenuse. Then we go for cos theta. That is the cosine of theta. This is sine of angle theta. This is cosine of theta is adjacent over hypotenuse. So we have it as adjacent over hypotenuse. And the third one out of the three basic trigonometric ratios, we have it as tangent, tan theta. Tan theta is opposite over adjacent. So we have it as opposite over adjacent. Then from here now we can create an acronym from the first letters. So from the first letter here, we have the acronym as SOH. We have it SOH. Then the second ratio, you have CAH, CAH, and the last one is TOA. It is very popular as SOHCAHTOA. SOHCAHTOA, where S means the sine of the given angle is equal to opposite over hypotenuse, while this one is the cosine of the given angle to be equal to adjacent over hypotenuse, and the tangent of the given angle is opposite over adjacent. So these are the three basic ones we're going to be making use of in this video. So we go into solving problems, starting from problem 1. For problem 1, find the sides of the triangle labeled A, B, and C in the diagrams below. So we have this diagram with letter A or side A unknown, the second triangle with B unknown, and the third triangle with C unknown. The diagrams are not drawn to scale. Okay, so we start the solution from A. First, let us identify the given angle, which is theta, and that gives 40 degrees. Then the next thing is hypotenuse. By giving hypotenuse to be equal to 10 centimeters. Since this side is opposite the given angle, we have opposite to be equal to A. So these are the ingredients we need to solve for A. Then we now look at, from the trigonometric ratios, which one is combining hypotenuse and opposite. So it is so that is going to be used to get the value of A. So we now say sine 40 degrees is equal to opposite. Opposite comes first, that is A over hypotenuse, that's over 10. So we now make A the subject of the relation by cross multiplying. A is equal to 10 sine 40 degrees. So the value of sine 40 degrees can be obtained from either the table or from the calculator. So that's going to give us 10 times 0.6428. So simplifying this, we have it as 6.428 centimeters. So we're done with A. We then move to B. So for B, the given angle is 32 degrees. So we have theta to be 32 degrees. And if you look at this, hypotenuse is given. The hypotenuse is given to be 15 centimeters. Can you see that? Then B is the adjacent because this is opposite. B is the adjacent, so adjacent is equal to B. We then look for which of the ratios will combine hypotenuse and adjacent. So it can be TOA, it can be so it is CA. So we have it as CA, that is cosine of angle theta is equal to A, that is adjacent over hypotenuse. Cos 32 degrees now is equal to adjacent, that is B, over hypotenuse over 15. So we make B the subject of the relation, as B equals 15 cos 32 degrees. If we obtain the value of cos 32 degrees from the table, we now have 15 times 0.8480. Multiplying this out now, we have from our calculator 27.136 centimeters. And that's all for B. We then go for C. For C, we still come up with our theta to be 56 degrees. Our theta is 56 degrees. We don't have business to do with hypotenuse. So we are given opposite. That is, opposite is equal to C. And adjacent is equal to 7. We've gotten this. We now look at the trigonometric ratios that combine opposite and adjacent. So it is going to be TOA. So T means tangent of angle 56 degrees is equal to opposite C over adjacent. That's going to give us over 7. So we make C the subject of the relation by applying cross product rule. So we are going to have it as 7 times 56 degrees. We then find the value of tan 56 degrees, multiply by 7 to give the value of C. So we have 7 tan 56 degrees is going to give us 1.483. So 7 times 1.483 gives 10.381 centimeters. You might be required to reduce or maintain certain degree of accuracy as you present your answer. It could be 3 significant figures, which is going to give us 10.4. It could be 4 significant figures, which is 10.38, or it could just be in decimal, 1 decimal place, 2 decimal places, and so on. So that's all for problem 1. We then go to problem 2. For problem 2, calculate the angles of the triangles below. We have triangle A and B. So we are going to label the angles as alpha. Then this one should be what? Beta. This one is going to be theta. And this is going to be delta. For problem A, we are to calculate alpha and beta. And we need to look at alpha facing the opposite side, and this is the adjacent. So we can say to calculate alpha, tan alpha, that's opposite over adjacent. So we are going to have it to be equal to 5 over 6. 5 over 6 is 0.8333. Then we find our alpha. You either use calculator or mathematical tables. So we now have alpha to be 39.80 degrees to 2 decimal places. So for A, we are done with the alpha. So we can then calculate beta. So to calculate beta, we have it here. We said alpha plus beta is equal to 90 degrees because they are complementary angles. Since this is already 90 degrees, so the sum of alpha and beta will give 90 degrees. So that is what we just demonstrated here. So we now have beta to be 90 minus 39.80, which is going to give us 50.20 degrees. So we are done with A. We then go to B. For B, we are considering calculating theta first. So to calculate theta, this is opposite and hypotenuse. So with the opposite and hypotenuse, we are going to make use of sine theta degrees is equal to 3.2 over 7.3, and that gives 0.4333. Taking the inverse of theta, so we have theta to be sine inverse of 0.4333, which gives 25.68. Then we go ahead again to calculate delta. So to calculate delta, we still apply the principle of complementary angles. So in that case, we have theta plus delta is going to be 90 degrees. It is complementary angles. So we go ahead to find the value of delta by subtracting theta from 90. So we have it as 90 minus 25.68 degrees, and that gives 64.32 degrees. So we have done justice to problem 2. We then go to problem 3. For problem 3, calculate the value of A and of B in the diagram below. So we start the solution of problem 3. First, we are going to calculate A. So because we cannot calculate B until we get A. So from this triangle here, the larger triangle, that is the larger right-angled triangle, opposite is A and adjacent is 12. So opposite and adjacent is going to be 12. So that to calculate A now, we say tan 35 degrees is equal to opposite, which is A, over adjacent 12. So we can get the value of tan 35 degrees either from the mathematical table or from our calculator. From the calculator, we have 0.7002 is equal to A over 12. If we then cross multiply, you see we are going to have A is going to give us 12 times 0.7002, and that gives 8.4024 centimeters. So if we like, we can try to round off the numbers. Let's say to 3 significant figures, 1, 2, 3. This is now up to 5. So we have our answer as 8.40 centimeters to 3 significant figures. So we go ahead to calculate B. Remember, we're going to be making use of the value of A. So from the smaller right angle triangle, this is opposite and hypotenuse. Sine. To calculate B, that's going to give us sine 42 degrees. So we have opposite, which is B, over hypotenuse, and our hypotenuse is A. We've gotten the value of A to be 8.4024. So the value of sine 42 degrees is 0.6691. It's equal to B over 8.4024. If we cross multiply now, we are going to have B to be 8.4024 times 0.6691. So simplifying this from our calculator, we have it as 5.622 centimeters. So to three significant figures, we have 5.62 centimeters, three significant figures. So that is all for problem 3. We then go to problem 4. For problem 4, in the diagram, AC is perpendicular to BD. This is AC is perpendicular to BD at point C. ABC, angle ABC is 51 degrees. Angle CAD is 61.3 degrees. And AD is 10 centimeters. Calculate BD. We have to calculate BD. From our solution, BD is BC plus CD. BC plus CD. So we'll be required to calculate BC and CD, add them together to give us the value of BD. And to do that, it is easier to calculate CD because if you look at angle ABC, there's no any side that is given. So it's better we calculate this one. It is easier. Then later we calculate AC before BC. So to calculate CD, we consider triangle ACD, and from there, CD is the opposite, and this is the hypotenuse. The ratio combining opposite and hypotenuse is sine. So we now have it as sine 61.3 degrees is equal to CD over 10. Since opposite is CD, hypotenuse is 10. The value of 61.3 degrees is 0.8771, which is equal to CD over 10. So making CD the subject of the relation, we have it as 0.8771 times 10, which gives 8.771 centimeters. Then we go ahead now to calculate our AC. We still use the triangle ACD to calculate AC. So to calculate AC, we'll be looking at adjacent and hypotenuse. Adjacent and hypotenuse, that is cosine. So we're going to use CA since it is adjacent and hypotenuse. So we have cos 61.3 degrees is equal to our adjacent, which is AC, over hypotenuse, which is 10. The value of cos 61.3 degrees is 0.4802 is equal to AC over 10, where AC is 0.4802 times 10, and that gives 4.802. We then go ahead to calculate BC. So to calculate BC, we'll be looking at angle ABC. Angle ABC. So we've gotten AC, BC. This is opposite and adjacent. So the ratio there is 2, which is going to give us tan 51 degrees is equal to opposite. Our opposite is AC. Then our adjacent is BC. That's going to give us over BC. Now, we've gotten our AC to be 4.802. We then find the value of tan 51 degrees, which is 1.235, is equal to 4.802 over BC. So making BC the subject of the relation, we're going to have 4.802 over 1.235, and that gives 3.888. So that we can now go ahead to calculate our BD, since we've gotten BC to be 3.888, CD to be 8.771. So BD now is equal to 3.888 plus 8.771. That is giving us 12.659. To three significant figures, we have it as 12.7 centimeters. And that's all for problem 4. We then go to problem 5. For problem 5, in the diagram, calculate correct one decimal place, AC and AD. So in our solution, so starting from A, we have to calculate AC. So from triangle ABC, so we need to identify the sides. This is opposite, 12, and AC we are calculating is adjacent. So the ratio is 2. So tan 53 degrees is equal to 12 over adjacent, opposite over adjacent. That's giving us 1.327 as the value of tan 53 degrees is equal to 12 over AC. Making AC the subject of the relation, we have it as 12 over 1.327. Simplifying this from our calculator, we have 9.043 centimeters. We have to correct one decimal place. One decimal place here is 0, since the 4 is not up to 5 to be rounded up. So we round down the 4. That gives our final answer as 9.0 centimeters to one decimal place. Then we go ahead to solve B. So we have to calculate AD. So we look at triangle ACD, and we've calculated AC, which is now the hypotenuse, and we're looking for AD, which is now the opposite. So opposite and hypotenuse is sine. So we have sine 44 degrees is equal to opposite AD over 9.043. And the value of sine 44 degrees is 0.6947 equal to AD over 9.043, making AD the subject of the relation. We're going to have it as 0.694 times 9.043, and that gives 6.2822 centimeters. And to one decimal place, we are going to have it as 6.3. This is 8. We round it up by adding 1 to 3 to give us 6.3 centimeters. That's all for AD and the entire problem 5. We then go to problem 6. For problem 6, in the diagram, ABC is an isosceles triangle of height h centimeters. Isosceles triangle, height h centimeters. AC is equal to BC. AC is equal to BC and is equal to 3x centimeters. And AB is 2x centimeters. Calculate the base angles of the triangle. Hence, find the value of h in terms of x. So we go for the solution of the problem. Since AB is 2x and this height is the line of symmetry of the isosceles triangle, which means this point is a midpoint, and at that point this AM is equal to MB, and they will give us x centimeters each since AB is 2x centimeters. So we can now name one of the base angles as theta. We concentrate on it. So we can say from triangle ACM, this is opposite, this is hypotenuse, this is adjacent. We have to calculate this base angle. It is better we go for x and 3x, so adjacent and hypotenuse. We might not be able to resolve the h with x. We're then going to use adjacent and hypotenuse. So cos theta is going to be adjacent, which is x over 3x. That is the hypotenuse. X will cancel, x will be left with 1 over 3, which is 0.3333. So theta is cos inverse of 0.3333. From the calculator or from a mathematical table, we have theta to be 70.53 degrees. So with this, we've gotten the base angles which are equal. And they have them as ABC, that is ABC. The other base angle is equal to BAC, and we have it as 70.5 degrees to 1 decimal place. We are then to find the value of the height in terms of x. To calculate the height h, we still look at the same triangle ACM, which is CM is the height, and opposite we can use sine. So we have sine 70.53 degrees is equal to opposite, which is the height, over hypotenuse 3x. It is also possible we use tan, giving us opposite over adjacent. We still get the same answer. For your information, I'm not using the approximated value here. I'm using the raw value. If you use this, we call it premature approximation. Okay, so we use the unapproximated value in subsequent calculation, not the approximated value. So making h the subject of the relation, we have h is equal to 3x times 0.9428. The 0.9428 is the value of sine 70.53 degrees. So from our calculator, we have it as 2.8284x centimeters. And to three significant figures, we have it as 2.83x centimeters. This is 2, third significant figure, and the fourth one is 8. We round it up, add 1 to this 2 to make it 3. That's all for problem 6, and this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Don't forget to subscribe to our YouTube channel. Also remember to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on trigonometry. Don't also forget to visit our website for easy access to all our videos on our YouTube channel. Until we come your way again, goodbye.